Excellencies, dear guests from the Diplomatic Corps in Slovenia, dear colleagues, I'm happy to welcome you in the name of all my colleagues from the Research Center of Slovenian Academy of Sciences and Arts. As you will hear more about the details concerning KARST research from my colleagues, I would just like to emphasize that interdisciplinarity, which is the critical condition of such work. Not least the study of the KARST shows one of the important advantages of our center, which, as some of you might know, consists of 18 institutes in various fields of humanities and social and natural sciences. For these reasons, our colleagues from KARST Research Institute located in Postojna can find quite a few competent research partners in their own institutes and in their own institutions. Researchers from the Institute of Geography, Paleontology, Biology, and Archaeology can offer them quite a bit of their specific disciplinary knowledge. My second task today is to introduce the course of today's event. In order to cover all above mentioned areas, we decided to offer you a series of short contributors with their contributions. With the exception of Nadja Zupan Hajna, who is one of the initiators of today's event, each of presenters will point out some central topics of his or her research areas, and in this way we'll probably gain some time for informal discussion at the end of the presentations and while seeing or looking at the exhibition that you can see here on both sides. Thank you very much for coming here today, and I hope you are going to enjoy the event. Now, let me translate myself shortly in Slovenian. Spoštovani kolegice, kolegi, ekscelence, prej sem v angleščini pozabil upravičiti predsednika Slovenske akademije, ki me je za to eksplicitno prosil in to zdaj opravim zdaj. Prav tako se je upravičila tudi nemška veleposlanica in je prosila, da naj vas v njenem imenu tukaj pozdravim. Sicer pa me veseli, da se je našemu vabilu odzvalo toliko predstavnikov veleposlaništev diplomatskega zbora tukaj v Sloveniji. Kot ste razbrali iz mojega angleškega dela, sem želel predstaviti interdisciplinarnost krasoslovnega raziskovanja, brez katerega, kot boste videli v prezentaciji, v resnici na tem področju ne gre, in na kratko skušal predstaviti potek dogodka, kar pomeni, da bomo zdaj na začetku lahko videli kratek predstavitveni film, potem bo pa moja kolegica in organizatorja in pobudnica in organizatorka današnjega večera, doktorica Nadja Zupan Hajna, nekaj več povedala tudi o Mednarodni krasoslovni in speleološki zvezi. Vsak od kolegic in kolegov bo pa v kratki prezentaciji poskušal predstaviti to, o čemer sem oziroma na kar sem opozarjal, torej interdisciplinarnost tovrstnega raziskovanja. Torej, tudi vsem Slovencem in Slovenkam, torej slovensko govorečim, želim prijeten večer, žal tokrat brez prijema, ker tako narekujejo okoliščine, zato smo se pa že v zadnjih dneh in tednih pogovarjali, da bi podoben dogodek ponovili spomladi, ko vas bomo lahko povabili v Postojno in tam povedali več o raziskovanju naših kolegic in kolegov. Še enkrat dobrodošli. Zdaj pa sledi film in nato kolegica Nadja Zupan Hajna.
Life. Percent of the world's groundwater is in karst areas, hidden in the dark of our Earth. At a rapid speed, the water flows underground through these karst landscapes, forming in part extensive cave systems, and returns to daylight unfiltered from springs. About 700 million people worldwide source their drinking water from karst groundwater. These include large cities such as Rome, Vienna, and Damascus. Karst areas and their caves can be found all over the world. Although they look different externally, they all drain water underground. In order to teach everyone about these hidden worlds, 2021 has been declared the International Year of Caves and Karst. This is necessary because these landscapes, which took millions of years to create, are threatened with destruction and poisoning within a few human generations. This is done partly out of ignorance. Few people see what is under their feet. Most of our knowledge of karst comes from cavers and scientists who descend into these hidden worlds to explore them, increasing knowledge to preserve these fascinating resources. Caves make it difficult for researchers. Deep abysses, bottlenecks, huge halls, passages underwater, crashes. Cave systems can be very complex. The longest extend hundreds of kilometers. And the deepest is more than 2,000 meters. Despite all of the challenges, cavers bring light into these unknown worlds. Wonder worlds, full of bizarre beauty and an immense wealth of forms. More than 90 UNESCO World Heritage Sites and more than 70 global geoparks are in cave and karst areas. Every year, hundreds of millions of people visit the world's show caves, making them important economic engines for entire regions. Cavers observe, measure, take samples. Tens of thousands of kilometers of caves have been discovered, mapped, and documented by them. This basic research forms the basis for further studies. For example, dye tests to track the course of the water. But it's not just the water that's of interest. Caves harbor valuable climate data, and their sediments house archives of past life. Caves have always played a special role in human history. From the beginnings of human culture to the present day. However, the most recent things that people have brought into caves do not belong to our glorious heritage. They endanger not only important drinking water reserves, but also fragile underground ecosystems. Caves contain a diverse and rare, highly specialized fauna, which also benefits humans. Bats alone help produce more than 450 products in food, medicine, and industry. In 2021, the International Year of Caves and Karst, cavers and thousands of their friends worldwide will promote understanding and protection of caves and karst with events around the world. Coordinated by the International Union of Speleology, the global organization for caves and karst. We invite everyone to join the International Year events in their areas and learn more about the fascinating world of caves and karst.
So this was the start with our presentations today. Your Excellencies, distinguished guests, colleagues, I greet you here in this afternoon, also in the name of the International Union of Speleology, which actually declared the International Year of Karst and Caves in this year, but because of the COVID pandemics, it is also extended to the next year. It is honor for me to talk about karst caves and their relation to people, because, as you heard, this is the International Year of Karst and Caves, which was declared by the International Union of Speleology, which was actually founded in Slovenia in 1965 during the 4th International Congress of Speleology. Since 2002, it's also registered in Slovenia, and it has its seat at the Karst Research Institute in Postojna. International Year is organized by the more than 100 partners all around the world with the international organizations, national organizations, caving clubs, institutes, and so on. And there are many events which were already over, and some of them, they will be extended into next year, as I mentioned, and one of the most important until event, which is finished, was 2 months ago at UNESCO headquarters in Perez, which was organized by the International Union of Speleology and the permanent delegation of Slovenia to UNESCO, under the patronage of the General Director of UNESCO, to present karst and caves also to the national delegates at UNESCO, and the importance of karst and caves in our lives. One of the events, which is in next week and which will somehow close the events, it will be the 18th Congress of the International Congress of Speleology, also in France. When we think about karst and caves, we usually have association to famous tourist caves, stalagmites or stalactites, or UNESCO World Heritage Sites like South China UNESCO Karst, or Cini of Madagascar, or our Scotian caves, and so on, or to the cave paintings or other famous cultural heritage related to the karst and caves. But karst, it's usually indistinct landscape with no water on the surface, and there is also not a lot of soil on the surface. So karst was never densely populated because of that reasons. And what is karst actually? It is the landscape which is formed on the soluble rocks which were dissolved, and specific type of the relief was formed with the underground drainage and big caves. And these karst landscapes are formed on the carbonate rocks or evaporites like gypsum and salt. But the classical karst, it's developed on the limestones mostly. So the karst landscape occupy about 20% of the continent surfaces, but because these soluble rocks are present in different climatic environments, also the karst landscapes are represented in various types. So around the world we have karst landscapes which are very similar, but on the other hand very different. But solutional features and caves we can find also in less soluble rocks, like granites or quartz sandstones, and caves can be formed also in glaciers or in lava, but they are formed by different processes as classical karst. As I mentioned, on the karst there is no water on the surface mostly. All the rain just is infiltrated underground, and rivers are sinking also deep inside. So the water is accumulated down below, and it rises to the surface just in big karst springs. On the surface, we have many different karst forms, from very small ones to the big one. The one which is produced by the dissolution of soluble rock by rain, there are different various types of current. And the dolinas, these are oval-shaped depressions, which are characteristic for temperate climatic zones, and they are produced by different processes like solution, collapse, subsidence, and even suffusion. And the biggest karst depressions are karst polyas, with flat bottoms and sinking rivers. During the high water level can be flooded, and in the dry season, the water table is below the bottom of the karst polyas. Cone and tower karst, typical for tropical karst, for tropical areas, while deep caves and the deepest caves of the world are present in the high mountains. Caves can be formed by different processes, but the most important is the dissolution, which is going on along the open fissures, where the water can precipitate inside into the cave from the rainwater, from meteoric water, or from the water which rise from deep below. So there are two types of caves. Caves can be horizontal or vertical. They can be of various cross sections. They can be filled with water, air, or they can be flooded. And most of the caves of the world, it is formed in the limestones. Some of them are also formed in gypsum, and if they are in dry climate, we can also get caves in salt. That's usually connected with the appearance of the salt on the surface. Caves go through their lifetime through different stages. They are formed deep in the phreatic conditions like conduits. They grow during their lifetime, as may say, and they can be filled with the sediments, and then at the end they come to the surface because of the surface dissolution. And they are exposed to the surface, and we know that they are unroofed caves because we can find cave sediments there, even the speleothems, or they can remain as the natural bridges. These are the past caves. In caves, we can find different deposits, river deposits, also rare minerals or various paleothems. We can also find ice if there is good climatic conditions in the caves. And all caves, most of the caves are inhabited with the animals. In some, the animals just visiting the caves, or they are living part of their lives underground, while the others, the true cave animals, are living through all their lives underground, and they are adapted to the extreme conditions of that environment. And from the animals, we can after find paleontological remains, also extinct species. So we can interpret the past from their remains. And also there are many archaeological remains which are giving insight into the human history up to 3 million years behind. And that's because caves were always used by humans as shelters, dwellings, or religious places, or for other things. And the first settlements were built next to the big karst springs, and they were very important for water supply. But with the growing population, the people causes the many different problems to the karst, from the industry, intensive farming, even mass tourism. We can get pollution, and this pollution can enter and be infiltrated into karst and pollute the karst waters and caves and even the environment where the specified fauna lives. And that is because the characteristic of karst, where we have open fissures and open channels where water flows from the poners towards the spring, and there is no cleaning of that water because there are just open channels. So what can be done? One thing is that we have to recognize the karst landscapes, and that we have to know how it looks, that we know what the problems can be there for the water supply and other problems. So the first, it's very important that we know what is beneath us. We have to explore the caves which are below, and that's usually done by cavers. They are collecting data about the caves, which can be then used for science or for the karst managers. And when we know where the karst is and where the caves are, we have to understand how karst is functioning. Lately, many interdisciplinary and comprehensive studies are done on the water drainage and water tracing, then cave climate, and then also the climate changes and also the impacts of the environment. But about that, we will see and listen more in the following program. So when we know where the karst is and where the caves are, and we understand how it's functioning, we can protect karst and caves. So with different kind of laws, regulations, and even with guidelines to the tourist visits of the caves and also the common visits of the caves. And with the monitoring, we can also take proper management of the sustainable management of karst landscapes. But the best protection for karst and caves, it's education, from the schools up to the scientific conferences, presentations, lectures, like one of them is today. So because of that, International Union of Speleology with its partners declared this year for the International Year of Caves and Karst, and we held the presentations, workshops, scientific conferences, and so on, all around the world. And for one of these occasions, I also published the book Karst, Caves and People with cooperation of 64 authors from 18 countries around the world. And many of these photos were now used in this presentation, and they were also used for preparation of the posters, which you perhaps notice when you enter this hall. So these are the photos. And just to mention, here at site we have also the exhibition on karst and caves in Slovenia, which was done by the authors from the Slovenian Caving Association. So this you can also look at the end. And to finish this presentation, I just have to say that it's very important that we know and that we recognize the karst and caves and their importance in our lives, and that actually the future of karst and caves is in our hands. So with this, I finish the presentation, and I will give the word to the head of the Karst Research Institute in Postojna, who will talk about the karstology of classical karst, which will be followed then with the highlights of the caves and karst studies by the colleagues from our institutes.
Spoštovane, spoštovani, dober večer. Na klasičnem krasu razvijamo klasično krasoslovje. Ladies and gentlemen, good evening. In the classical karst, we are developing classical karstology. Almost half of Slovenia is a karst, and more than half of the waters with which we are supplying is from karst aquifers. Our karst has given the name for the landscape developing in carbonate rocks, and with its description, karstology has started to develop. In the comprehensive way, we are deepening the knowledge about karst, which is also the base for the proper planning the life in karst, its protection, and also for the study of karstology. In the understanding of three-dimensional karst landscapes, we are connecting the different approaches from karst geology, geomorphology, speleology, karst hydrology, biology, microbiology, ecology, and karst development. It's very important to know very well the characteristics of the carbonate rocks and their influences on the development of karst features. Stone forest in China, we are working there more than 20 years. Important role in the development on the karst surface and caves has also tectonics. For example, we are measuring micro movements in the caves. The eldest features in karst are paleokarst features, which are covered by younger rocks. We are researching, of course, karst surface from largest features as karst polje is. This is the Planinsko polje during the high waters, to the inscriptions on the rock, which shows us quite a lot about the development of the karst surface. In this way, we are trying also to recognize differences or typical shaping of the karst surface in the different circumstances and in different carbonate rocks around the world. Water is dissolving the rock, and karst surface is lowering, enriching the caves, and unroofed caves are important part of the karst surface. With cavers, we are collecting data about Slovenian caves in the register of the cave, and already known is more than 4,000 caves in Slovenia. It's very important to understand well the processes of dissolution of carbonate rocks and the position of calcite in the caves. And also the shape of the cave can tell us a lot about its development. The development traces we can find also in the deposits and flowstone in the caves. They are not important just to know how old the caves are, but also to understand development of wider region of karst. For example, we have here an old cave in the top of the mountain, and from the traces in it, we can see that this part of the Alps had elevated in the last 2 million years for 900 meters. We are developing also the approaches of the research work for field 1 to mathematical and computer modeling. Later we will hear more about this. And a special attention we are dedicating to the research of karst water. With the colleagues from Slovenian Environmental Agency, we prepared a database of underground water connections. The water tracing is one of the most important way of research of the karst waters. Here is one example. Ministry of Defense asked us to check where the waters from our main military training area are flowing. We put tracer in one dolina here and found it in all springs around. So according to these results, should be also our behavior on the surface. We would like to know whole karst aquifers. This is classical karst in the cross section. Through deep caves, 200-300 meter deep caves, we can reach underground water. And modern technology enable us permanent measurement. The water in the karst aquifers is oscillating and in different hydrological conditions flow in a different way. So we have enough comprehensive knowledge to get good water out of the karst aquifers. In this way, we are also looking for new sources of the water, and we are also studying the vulnerability of karst aquifers. The karst underground in this climatic belt is one of the richest regarding the biodiversity. And our caves are a real hotspot for caves biology. A lot of new data we got about the life in the underground and our influence in it. We get also through the cave microbiology researches. Due to the rich history, we are researching the history of the karstology and speleology. This is the Valvasor sketch of functioning of karst, Cerkniško karst polje, and the eldest map of cave in Slovenia from 17th century. We are involved also in planning the caves for the tourism. So we are developing so-called climatic biological monitoring, and the data we get from this are very important also for the management of the caves, for further development and protecting of the caves. We are involved in several so-called applicative projects. Just one example, during the construction of 75 kilometers of motorway in western Slovenia, 350 caves opened. We were trying to preserve as many as possible, but result of research work were also very useful, where we were planning the new railway connection from inner Slovenia to the coast. We were trying to predict what kind of the caves will open, how the water is oscillating in the aquifer. And we were avoiding all already known features. Here we move a little bit this right away of the railway from the already known cave, for example. We are collecting our knowledge and editing the Acta Karstologica, which is one of the most important international karstological review, and larger studies are joined in the series of book. We have established also study of karstology. This is unique such study in the international level when you can get title Doctor of Karstology, and it has become also the UNESCO chair on karst education. This is the first UNESCO educational chair in Slovenia. We are organizing also International Karstological School, the largest yearly meeting of karstologists. Here, as Nadja said, is also the seat of Union International of Speleology, which joins thousands of cavers from the whole world. We all know that science is possible to develop just in a tight international cooperation. So we cooperate with the karstologists from the whole world, and with several we have signed also agreement for tighter cooperation. With the colleagues from Yunnan University, we have established in Kunming in China, International Joint Research Center. We are helping to develop the karstology in the different countries around the world. And more karstological data are collected in so-called European infrastructure nets, and we are leading, or we are coordinating work in the national level in 3 of them. 2 are dedicated to the biodiversity and 1 to the geophysical researches. We all know that sustainable development is possible just as a comprehensive social, democratic, and environmental goal. We are thinking about European Karstological Center here in Slovenia, and we are thinking about the karstology as a special branch of science. But first of all, we will do our best to develop Slovenian karstology as an important international research and study center. Thank you.
Dober večer. Good evening, and thank you to the organizers for preparing this event. I am Andrea Martin Perez, and I work in the Institute of Paleontology, Ivan Rakovec. Speleothems is how geologists call the mineral deposits that grow within caves. It's what most people call simply cave formations, flowstone, or in Slovenian, siga or kapnike. The most known classical speleothems are stalactites, stalagmites, or columns, which are formed by calcite and are usually layered. And they can be very useful for the study of past climates, like we will hear in the following talk. By contrast, unusual speleothems are cave deposits with uncommon morphologies or mineralogy. They are not layered, and although they are not useful for paleoclimate, they can be very relevant for other disciplines in sedimentary geology. We will begin with dolomite speleothems. Dolomite is a calcium and magnesium carbonate, very similar to the mineral calcite. Dolomite in caves form crust in well-ventilated areas where there is a dolostone host rock. Dolomite occurs at spheroidal crystals, as we can see in this optical microscope image, where the white mineral, the white spheres, is dolomite and is replacing aragonite, which appears here in red. Here we see the similar process, dolomite growing over aragonite, but in 3D under a scanning electron microscope. The importance of dolomite is that it's a very peculiar mineral because it's very common as a rock, but it's scarce in modern environments, and it has not yet been synthesized in the lab at low temperatures. This controversy is known in geology as the dolomite problem, and the study of cave dolomite can contribute to resolve it. Cryogenic cave carbonates form on the surface of ice. Here we can see an ice stalagmite, and the particles which are signed by an arrow are cryogenic calcite. These carbonates are fine-grained powers of various mineralogy, and they form by fast freezing in well-ventilated cave entrances. In this detail, we can see the particles of carbonate forming along the frozen drips. When we collected samples during the summer, so that's it, just powders on the floor, and we observe them under the microscope, they are formed by calcite, with this appearance. But when we collected in situ samples of ice and carbonate during the winter, and we observe them still frozen under the SEM, they are formed by this mineral, vaterite, which is a metastable polymorph of calcium carbonate. But we have also seen, like it's in this example, rhombohedra of calcite and spheres of vaterite together, which probably means that vaterite transforms very quickly into calcite. So cryogenic cave carbonates precipitate by the segregation of solutes during the freezing of water when seasonal ice forms near cave entrances. They can offer important information about recent climatic conditions at the cave entrances or early transformations of metastable minerals. To finish, we will speak about moon milk, which is a very peculiar speleothem of cloudy and white appearance. And the moon milk stalactites, like we see here, have a flat bottom, and they are usually wider and shorter than the normal stalactites, which we can see on the top left, those orange. The most peculiar characteristic of this material is that it's completely soft. These stalactites are soft due to the high porosity and content of and water content. This texture, so peculiar, is due to the microstructure of moon milk, which is formed by tiny fibrous crystals of calcite that forms very porous aggregates. Moon milk is very rich in microbial biomass, and sometimes we can observe the microbes under the SEM, like we see here, that arrow marks it. And it's also rich in organic matter, which may play a role in the precipitation of the calcite in these speleothems. But summarizing, there is still many open questions regarding moon milk. To begin with, its origin, which is still controversial. Precipitation of moon milk could be purely physicochemical or could be affected by the activity of microbes or by the presence of organic matter. And we still don't understand why moon milk forms in some caves but not in others. So understanding moon milk formation will be an important contribution to geomicrobiology. So here we conclude, and I hope I have been able to show you that despite rare or less spectacular, unusual speleothems can be very relevant in important topics in sedimentary geology, and in particular in carbonate sedimentology. Before I finish, I would like to thank all the co-workers who have collaborated in this research, and also all the people who has helped us in the field and in the lab. I hope I haven't forgotten anybody. And thank you very much for your attention. Thank you.
Okay, my name is Jure Tičar, and I come from Anton Melik Geographical Institute. So with such a great number of caves and constant quality speleothems, stalactites that grow from the top and the stalagmites that grow from the bottom, we have an opportunity to analyze the past climatic events in Slovenia, in particular from stalagmites. We can take a stalagmite as an enormous floppy disk. It has stored information from the beginning of its growing, as we can see here, to the very top part, which is at the end of its lifetime, up here. So every time the stalagmite grows for a bit, it basically stores the information of climate and even vegetation outside the cave. And our challenge is to extract this data and to turn it into information that is useful for humanity. Everyone has probably seen this very generalized climatic curve. We are showing here the last 350,000 years, and a great part of these years was characterized by ice ages. However, what is really important for us is to focus on the last 10,000 years during the Holocene, when the ice age is gone away, but climate still remains changing. You might not see the changes on this graph, but let's look at it closer. This shows only the last 10,000 years, and we can see the dramatic change from the cold climate on the left to the climate with similar temperature as today, as presented here. But can you see the curve? It is varying up and down, and certainly has never been steady. which means that climate is keep on changing and the differences can be big when we compare America to Europe or even just small European regions between each other. Slovenia does not have the climatic curve developed yet, but we desperately need it because we know that there have been several occasions in the last 10,000 years when archaeological evidence suggests the old cultures were affected by probably changing climate. And we need to know how dramatic these changes were and what was the cause and how can we use this knowledge to either try to stop these changes in the future or at least prepare and be ready. So therefore, we are currently working on this challenge. And as you can see from the images, one part, this is continuous monitoring of perspective caves, including sampling of water and of course, sampling the stalagmites. Stalagmites are very fragile at the same time and at the same time very precious. So every step is made carefully and with an established collaboration of people from our institution, from other Slovenian institutions, and also from the institutions from abroad, because we are only using the newest and most reliable techniques that currently exist in the world. So the climatic curve for Slovenia is currently in the process, and we aim to develop the one which will be reliable, useful, and informative for further science as well as applied science and humanity. Thank you.
Well, good evening, everybody. My name is Mateja Breg Valjavec, and I come from Geographical Institute. I prepared this presentation together with my colleague Andraž Čarni from Biological Institute, and I will talk about dolines, about the karst surface. Well, dolines are enclosed karst depressions. They were formed by dissolution of carbonate rock. From the beginning of the karstic research, dolines were considered as diagnostic, the most typical karst surface landform. Dolines are also natural traps. They are oases of soil, which is very rare in the karst surface, actually. But in dolines, it's very rich. So soil accumulates in the bottom and covers the underlying rock formations. This is fine-grained, silty clay soil, and the layers of soil can be up to a few meters thick. Due to the fine-grained soils and soil thickness, karst soils in dolines have very high storage capacity for organic carbon. Organic carbon that is formed by biomass from forests or grasslands. So organic carbon is a part of carbon cycling, and it means that impacts climate. So dolines in which land use is grasslands, scrublands, or forests were recognized as sustainable soil organic carbon pools. They can, in average, store over 100 tons of organic carbon per hectare, and it means that they can actually mitigate climate changes. With the comparison with the outside surface, the organic carbon stock capacity is in dolines much higher. Due to evident topographic anomaly, this concavity, the microclimate in dolines differs a lot from the macroclimate of the surrounding flat plateau. On clear nights, cold air actually accumulates in these depressions, and because there is no wind, it stays in depressions. And during the day, as the surrounding air warms, it becomes lighter, and it doesn't mix good with this cold air, and actually dolines are causing an extended period of cold, and that's why thermal inversion appears in dolines and can be also marked by snow cover. In the face of global warming, it is important that dolines can be have great capacity to support cold-adopted species because of this cold air that is in the depressions. Microrefugia are small areas with high resistance to regional environmental changes, also to climate changes. And dolines are for sure these microrefugia in karst areas. Climate change as the best climate change refugia were recognized forested dolines. Dolines are most widely dispersed, most numerous, and most diverse surface landform on karst plateaus. In Slovenia, we have almost 470,000 dolines. Only on karst plateau, which is, you can see this is a plateau, it's a Kras plateau, there are over 14,000 dolines. Unfortunately today, Kras plateau and dolines are almost covered by forest due to natural afforestation because the land is abandoned. Through our latest studies, we established that only the dolines that are deeper than 13 meters can serve as good safe havens as climate change refugia for these called adopted species in the foreseen climatic changes. In Kras Plateau, there are many called adapted species in dolines. For example, here is one balm-leaved red dead nettle that likes colder climate of deeper dolines and cave entrances. Here it's a lot of this nettle, and there are many plants like this in Kras Plateau. And what will happen if the climate will actually change and these changes will become faster and the forest will disappear because of the aridity? In this scenario, Kras Plateau can again become karst rocky desert as it was already in the 19th century, but because of the forest cutting. The landscape can become similar to today's more southern European karst landscapes, for example, like Crete Island. On Crete Island lives an endemic plant species, which is found only in one part of Crete, and it lives in dolines, and it's called Horstrecia dolinicola, and bears the name of doline. It is a red leaf species, only 50 plants exist. So karst covers 20% of Earth's land and 33% of Europe. In many European karst landscape, we can find dolines that can either serve as safe havens for many cold adopted species or work as soil organic carbon pools. It is our challenge and our obligation to protect the dolines, especially those dolines that have the ability to mitigate climate changes and can serve as safe havens for endangered species. Thank you for your attention. Hvala za vašu pozornost.
Good evening. My name is Turk Mateja. I am an archaeologist from the Institute of Archaeology, and I will tell you a few words about archaeological research in the cave Divje Babe. The cave is situated in western Slovenia, in the valley of the river Idrica. It's Paleolithic and paleontological site. Interesting about this cave is that it's formed in dolomite and not in the limestone as the other Paleolithic cave sites in Slovenia. And so also the sediments in this cave were different. They are constituted mainly of silt and gravel and bones of Ice Age animals preserved perfectly in these sediments, and also other finds. Here are researchers of this cave. The excavation ended more than 20 years ago, Matija Breg at the right, and then Ivan Turk and Janez Direc. At the beginning, Matija Breg excavated in this cave for 6 years. He excavated the entrance of the cave and he wanted to reach the rock bottom of the cave. But the rock bottom wasn't reached, and we presume that the sediments go more than 10 meters deep. This stratigraphic profile at the entrance was 12 meters deep. Then Ivan Turk took the direction of the excavation, and he started to excavate inside the cave. The cable way was built to transport all the excavated sediment down to the valley, where sediments were put on meshes and water sieved and inspected. The excavated layers belong to the last ice age. All the layers were dated radiometrically, and the uppermost layers is 40,000 years old, and the lowermost layer is more than 100,000 years old. All the sediments were analyzed sedimentologically, chemistry was made, and in the basis of all this and radiometrical dates, the paleoclimate was reconstructed. Here at the left, we see this curve made on the analysis of Diababe sediments, and this paleoclimatic curve corresponds very well to the global paleoclimatic curve we see on the right. Also, 4 major gaps in sedimentation were identified, but we are more interested in finds. The cave was actually den for the cave bear, and a lot of bones, majority of the bones belong to the cave bear. In this sense, there is interesting the discovery of fossilized cave bear hairs. The sedimentological environment also enabled fossilized wood to preserve. A lot of charcoal and also pollen was found. Archaeological finds belong to Paleolithic. At the uppermost layer, there were finds of anatomically modern human. These are these bone points, very characteristic for this period, Ornithian. But most of the finds belonged to Neanderthals. Here we see typical stone tools made of local chert and tuff, and also bone artifacts. They are very rare in this period of Neanderthals. And of course, the most famous find is this so-called Neanderthal flute. Its age is between 50 to 60,000 years. Here we see the original and the reconstruction of this instrument. There were a lot of doubts about the origin of the holes, and very extensive experimental work was done to find out the origin of the holes. And all these results go towards opinion that the holes are made artificially, that they are not made by carnivores. Also, musical verifications were made, and the reconstruction of this instrument was made, and it functions very well as musical instrument, and actually it could be declared as a first known aerophone, and also the oldest musical instrument. This is all from my side, and thank you for your attention. Thank you.
Our colleague from the Institute of Anthropological and Spatial Studies is not here because he's on his way from the field work in Yucatan. So he prepared the presentation. that we can look now.
Dober dan. S tem prispevkom se bomo predstavili na drug konec sveta, namreč na področje mezoameriške arheologije, ki se ji posvečam že vrsto let, zlasti arheologiji Majev, katerih kultura se je razvila na jugovzhodu Mezoamerike, na nižavjih na jugu in v nižavjih polotoka Jukatana. Polotok Jukatan je pretežno ravna ali rahlo valovita apnenčasta plošča, zaradi česar so seveda zelo pogosti kraški pojavi, stalnih vodnih tokov skoraj ni, veliko pa je jam in na severu polotoka tako imenovanih cenotes. Čeprav naravne razmere niso bile optimalne, je prav v nižavjih kultura Majev dosegla svoj največji razcvet, ki ga danes opažamo v vrsti najrazličnejših arheoloških ostankov. Tako kot marsikje drugod po svetu, tudi pri nas v prazgodovini so bile jame tudi za Maje zelo pomembne. Jame so seveda vhodi v podzemlje, zemlja je bila vedno povezana z rodovitnostjo, velikokrat je v jamah tudi voda, zato so seveda v jamah vedno se najdejo tudi ostanki obrednih dejavnosti. Na severu polotoka so zelo pogosti tako imenovani cenotes, to so udornice, ki so nastale pretežno s podorom jamskega stropa. Največ teh jam je skoncentriranih vzdolž roba kraterja Chicxulub, ki je nastal kot posledica padca asteroida pred približno 65 milijoni let. V teh cenotes je praviloma dostopna voda, voda je v globinah med 10 in 25 metrov, zato seveda ni čudno, da so mnoga naselja zarasla v bližini teh cenotejev, recimo znameniti Čičenica, kjer je tudi posebno znan ta sveti cenote, do katerega vodi obredna avenija proti severu, in v katerega so metali tudi človeške žrtve. V srednjih nižavjih je voda veliko globlje, tudi na preko 100 metrov globine, in seveda ni bila dostopna s preprosto tehnologijo. Voda je dostopna samo v tako imenovanih aguadah, to so naravna jezerca, ki v mokriščih, ki se pa običajno izsušijo v sušni dobi, zato so Maji poroznost zmanjšali s ploščami, ki so jih polagali na dno, s kamnitimi ploščami ali celo s keramiko. No in v tem srednjem delu smo tudi mi vrsto let opravljali arheološke terenske preglede. To je bilo območje zelo slabo raziskano z arheološkega vidika, in v 11 sezonah smo našli preko 90 prej neznanih najdišč, med katerimi je tudi veliko jam, praviloma z obrednimi ostanki, keramika je tu, tudi ostanki konstrukcij. Jame imajo lahko vodoravne vhode ali navpične, in te vhode so Maji na simboličen način upodabljali v tako imenovanih zoomorfnih fasadah, ki na stiliziran način predstavljajo vhod v žrelo zemeljskega božanstva, torej jame. Eno od takih fasad smo našli tudi pred nekaj leti mi, je sorazmerno dobro ohranjena, čeprav manjka zgornja preklada, ampak dobro so vidni tudi te čekani zemeljske pošasti ob straneh. No, ponekod v srednjih nižavjih je voda zaradi geoloških prelomnic bliže površini in na enem najdišču smo našli modificiran jamski sistem, kjer je bila voda dostopna, o čemer pričajo tudi ti freatični kanali v stenah notranjih jamskih prostorov. Prav te naravne danosti so bile očitno odločilne pri izbiri lokacije za to naselje, ki se je izkazalo za eno najzgodnejših v srednjih majevskih nižavjih, kot so pokazala sondiranja in material. Najdišče je iz začetka prvega tisočletja pred našim štetjem. Mnoga naselja so v bližini aguad, marsikje najdemo tudi ogromne umetne rezervoarje. Mokrišča so prepredena s kanali, s katerimi so uravnavali vodne tokove in napravili vmes ležeča zemljišča bolj primerna za poljedelstvo. Večino pobočij so terasirali, s čimer so razširili obdelovalne površine, na njih zmanjšali erozijo in zadrževali vlago. Torej, Maji so se z razvijanjem tehnik intenzivnega poljedelstva in raznih metod upravljanja z vodo izredno dobro prilagodili na to neposebno gostoljubno kraško okolje. Hvala lepa za pozornost.
So, when Janez Vajkat Valvazor, a famous polyhistor, first described the use of caves as a convenient place for waste disposal at the end of the 17th century, he was unaware of the scale of the problem that would arise in the future. To him, this was just another habit of the local population, trying to protect themselves from disease or evil spirits, or to leave a mark in a mysterious underworld. Further exploration led to the discovery of numerous caves, and soon awareness of their fragility was awakened. With the increasing importance of science, especially karstology, caves are recognized as an important habitat and a gateway to karst aquifers, which supply water to at least 43% of the Slovenian population. At karst, as karst waters are extremely susceptible to pollution due to their low self-purification capacity, pollution can travel from the point of discharge to the springs within hours or days. Though, since 2004, the caves have been defined as natural values of national importance and are owned by the state and protected by the Cave Protection Act. Today, more than 14,000 caves are explored, and cavers discover more than 500 new caves each year. Yet cave exploration is not just about finding unusual formations, new passages, or scientifically important discoveries. Sooner or later, every speleologist comes across a pile of waste that has been thrown and forgotten at the bottom of an entrance shaft. What is cause of this rather unpleasant and disturbing fact that lies beneath our feet? The main cause is hidden in the period of the Anthropocene, known as the period of the Great Acceleration. After Second World War, the general economic development led to an increase in the amount of waste, while the lack of municipal waste management forced the locals to take the problem into their own hands. In the karst areas, it was therefore easiest to dispose of the waste in a nearby shaft, far from the eyes, far from the heart. Although some local studies were carried out and the level of pollution was estimated, there was no information on the level of pollution in caves throughout Slovenia. Since we have a sophisticated archive on caves in the form of cave register, we made it our task to find out more about. We have examined data from almost 7,000 caves and found that at least 20% of caves in Slovenia are polluted. This means that at least 2,500 caves are affected by pollution. In the Alpine karst areas, the level of pollution is low, as you can see here, around 6%, while in the lowlands it can reach up to 60%. As the problem is difficult to solve without a systematic approach, we have elaborated two models, one to predict cave pollution and one to prioritize the remediation of polluted caves. Nowadays, cleanups are done entirely by cavers, and so far about 200 caves have been cleaned. Since we tend to clean caves that are not very polluted, the most dangerous waste disposal in caves remains untouched. With the help of the Slovenian Research Agency and the Ministry of Environment and Spatial Planning, we will continue the pioneering work on cave pollution and its remediation. And a long-term goal is pretty simple. Wouldn't it be great if our grandchildren only read about pollution in history books? Thank you.
So last but hope not least, I will speak about the quantitative approach in understanding karst, or what we used to call modeling. You know, modeling can be all kind of stuff, but in this case I will be talking mostly about the mathematical and computer modeling of processes and forms in karst. Why do we do it? Well, there's two main reasons. One is to understand. You know, KARST is really a complex system of forms, but it's mainly, you know, it's mainly all this evolution is mainly governed by flow, dissolution, and mass and heat transport in soluble rocks. So we want to understand how all this happens. And the other reason to do modeling is, you know, to predict like where the pollutant will appear and when and at what concentration if it happens to enter the karst aquifer. So I will just now offer, among many models and modeling approaches, I will just give you I will offer a few, like, you know, peak views into some of these models. The first one, and the one we've been working on for over 20 years, are the models of speleogenesis, you know, how caves form. Why are we interested in how caves form? Because, you know, because they are there and because they are interesting and beautiful features, and caves are really inherent parts of karst aquifers, and caves and conduits actually characterize how the water flows in karst. And this is a simple example. You know, we just assemble a grid of fractures. We allow, you know, we do it in computer. We put in the equations of flow, dissolution, and transport, and, you know, it calculates how within this grid of initial fracture, which are just small sub-millimeter wide apertures, how within this grid cave system will evolve. And this happens after a couple of thousand years. And of course, with the model, we can now play with parameters, you know, what's the variety of caves which can evolve if we vary this or this parameter. If we change, we can change the input-output scenario. So we can really have insights into how processes form our underground. This is an example of an aquifer which forms due to mixing of two otherwise inaggressive water, but due to their mixing, there is an aggressivity, and, you know, after, in this case, 70,000 years, or I don't know, after several thousand or 10,000s of years, you might have a very interesting porosity below our ground that we are not aware of. Of course, we can also simulate situations like this. You know, we put dam site in karst area. So this is a dam. You know, on the left side you have a water accumulated, but of course we trigger a very high hydraulic gradients, and this water is pushed below the dam, and it came out. Actually, this model shows, and in real world cases show that in a couple of decades you can have a really high leakage that makes them unstable or unsustainable. The most widespread models generally are the models of groundwater flow, but in karst it's tricky. Your groundwater flow is mainly governed by the conduits. Most of the water flows through the conduits. And apart from those conduits which we explore, or some we detect by geophysics, we don't know where they are. So to model karst aquifer is really tricky. Here I'm just showing an interesting modeling approach that we use nowadays, where we actually neglect all the rest and just use conduits and do the hydraulics. This is, you saw it before, this is Kras plateau, and that's a cross-section of it. And already today showed that there is a really high variation of groundwater level when the flood passes through. The water rises for more than 100 meters. And we actually observed how this water rises with instruments which we place down at the groundwater level. And then, based on this observation, based on what we know about caves, and based on the equations of flow, we actually did a model which is very closely simulated to what we observed. And not only that, it also predicted channels which are not yet known. Well, we hope that somebody finds them sometime. So with models, we can also, you remember, I think in one of the Nadja's pictures, you have this nice cave channel which scalped all the way around. These scallops may tell us a lot about what was the flow going through the cave when this was formed, but we really need to have good insight into how they grow. And in order to do that, we also do models like, in this model, we used really true turbulent flow equations and turbulent transport, and in a way, it helped us, have a better insight into how these things form. And the last, but not least, again, is the stalagmite growth. Probably one of the oldest models in karstology, in karst research, was that of the stalagmite growth, because it's nice. Stalagmites are nice, and it's also the growth model is fairly simple. And there on the right, you have, a digital stalagmite, let's say, where the change of its shape is simply governed by the change of the recharge on the top. Why is it important? Because they are beautiful, and because, as Jure has showed us, stalagmites are important proxies of paleoclimate. So in a way, to really read the paleoclimatic signal from them, we need really good understanding of how they grow. And, we do models of all different kinds, recently we do quite a lot on cave climate or cave ventilation models and things like this. I'm not going to go any further from here. And what's important, and that's the end of my talk. Models really give us good insights, but we have to be careful when using them. We are working in poorly constrained systems, and modeler should not just, lock himself or herself into a room behind a computer and calculate what's going on in the nature. If nothing else, it's not healthy. A modeler should go out to see the nature, to observe it, to try to understand it, and then think about what equations to use. Thank you.
Dear guests, I hope that our presentations have given you an impression and insight into karst caves and human impacts in karst areas, as well as information about caves and karst studies carried out by the institutes within the Research Center of the Slovenian Academy of Science and Arts. Since we cannot enter the cave today, and we are very limited with COVID, for the end of the program, I invite you to a virtual visit of the Škocjan caves. Škocjan caves are listed on the UNESCO heritage site, and I think you know all this. They are close down to Divača. And with laser scanning, 2 years ago, we produced a 3D model of this cave and fly-through animation. And they were created from the drone images and obtained point cloud. So animation was done by the colleague Richard Walters from the United Kingdom. And all these results of the mapping and surveying provide valuable information for exploration and science, for the management and protection of caves, and also showing the caves to the people who cannot enter the caves. So we are now flowing between the two collapsed dolinas at the entrance of Škocjan caves. That's model and animation which was produced from that. We are in the bottom of collapsed dolina where water is flowing, the river, the Pono River, and now we go out through the shaft to the surface again. And as river Ponor into the Škocjan caves, we will also follow the river from the surface, from the bottom of Dolina, inside the cave. So there is about 6 kilometers of underground passages, about up to 100 deepers high. And this you can see the walls of the cave on the water path. So above us it was the bridge of the tourist path, And here we are now in the non-tourist parts of the cave. So this is the cave like it can be seen by the cavers, which you can notice them on the bottom of this model. They are very small because this is the second largest chamber in Europe and the biggest with the water. And the animation was produced from this kind of point cloud. So we produced this 2 years ago, and this is the 3D model of the cave. And this was done by our institute with the collaboration with the British Caving Association. But just lately, with the new European projects on the infrastructure, we also obtained our 3D scanner. So this is everything for today. Thank you very much. And I hope you enjoy our presentations as we also enjoy our presentations, which are done many times. Thank you very much to come.
Thank you very much for the presentations. Thank you for coming. We calculated that presentation should not be longer than 54 minutes. But you see what happens when the researchers get their words and they are in the position to present. They simply cannot look on the watch and be careful about the time. But we decided to do it in 2 parts. This, what we had today, is sort a seminar, and then in spring we are going to invite you to see some of the caves shown today. As Franci Gabrovšek told us, it's not healthy just to sit in the room in front of the computer or to be present at the presentation. You should really see, and as I said, you can expect the invitation to the second part, which is going to happen after April 1st. So once again, thank you to be with you, and now I would like to invite you to at least take a few minutes and look at the exhibition prepared by our colleagues from the Institute of Geography. And we have also some presents for you here in front. We have collections of our results. So if you're so kind to join me after I'm finished, so that I can give it to you. Once again, thank you very much in hvala seveda vsem kolegicam in kolegom, da ste bili danes z nami. Ko sem poslušal to prezentacijo, sem znova spoznal, da jih imamo premalo in da bi bilo pametno organizirati kakšno tudi iz drugih področji. Hvala vsem in upam, da se kmalu znova vidimo.